welcome to NSC 411 class. Biostatistics is the course title. My name is Olajide Omojarabi and I am your facilitator for this course. These are the course objectives. You're going to be looking at the definition and classification of statistics, stages in statistical investigation, definition of some basic terms. This is very important, very important. I mean, this guy here, definition of some basic terms. There are some statistical terminology that we are going to be using that are very important in this course. Definition of some basic terms. Afterwards, we'll be looking at the types of variables and measurement scale. This is another important aspect of the introductory part of this course. Introduction to biostatistics. Let's look at what is biostatistics. As a way of introduction, biostatistics is a growing field with applications in many areas of biology. That is the application of statistics in biology, including epidemiology. All these are the medical terminology, which is applicable in medical sciences, earth sciences, educational research, and environmental sciences. Basically, what we mean by biostatistics is just the application of statistics in biology or earth-related field. Concerns of biostatistics. We have applied statistics. That is one of the major concerns of biostatistics. These applied statistics. This guy. The application of statistical methods to solve real problems involving randomly generated data. What do we mean by randomly generated data? Randomly generated data are data that are gotten or that are chosen randomly. That is, they are subject to chance. It's not subject to bias. You just pick randomly. Maybe, for instance, if I have 1, 2, 3, 4, 5, 6, and I just want to pick a number, I just pick randomly whichever number that comes. And there are techniques in doing that. I may just pick using a systematic random sampling. That is, I might have to close my eyes and just pick any number. So whichever number I pick is the number that is privileged to be choosing. So no bias, no means of throwing them into investigation. Another concern of biostatistics is the biostatistics itself. That is the branch of applied statistics directed towards application in the earth sciences and biology. Very important, because as a biologist or a biological scientist, you should be able to analyze data. You should be able to speak facts with figures, and that is the major essence of this course. Classification of biostatistics. How do we classify biostatistics? Number one, descriptive statistics. Just as the name implies, a statistical method that is concerned with the collection, organization, summarization, and analysis of data from a sample of population is called descriptive statistics. What is a sample, by the way? A sample is just a subset of the population. Say, for instance, the total number of students at Thomas Adewumi University is a population, but the number of students in nursing department is a sample. I hope that is clear. Oh my God, what a beautiful course we are taking here. The other aspect of classification of biostatistics is the inferential statistics. This is just a statistical method that is concerned with the drawing of conclusions, making inference about a particular population by selecting and measuring a random sample. That is, when I want to deduce inference, that is, I want to hypothetically talk about what is happening around a particular data set. What I'm doing is what we know as inferential statistics. Yes, so when you look at descriptive statistics in general, We have raw data, and the data can be collected either by primary mode or secondary mode, and this data can be organized. It can, in fact, we can make sense from the data for the purpose of decision making. So under descriptive statistics, these are the ingredients that makes up descriptive statistics. There is what we call the measure of central tendency. Under the measure of central tendency, what we are talking about here is the mean, median, and mode. While under the measure of dispersion, we are talking about the variance, the mean deviation, the standard deviation, the correlation, the regression, and probably we may talk about the coefficient of variation. And that is what we are talking about. All this terminology might not make much sense, but by the time we look at illustrative example, it will make much more better sense. Measure of association, we're talking about test here. We are going to be looking at statistical tests such as the chi-square test, the analysis of variance known as ANOVA. So we look at the contingency table, histogram, the scatter plot, and the box plot, and so on. This is very interesting. Biostat is one of the aspects, in fact, it's one of the cores that you must understand. Okay, very, very important. Then we look at inferential statistics. Inferential statistics is the second aspect of the classification or the types of biostatistics. This branch of statistics deals with techniques of making conclusions about the population. Inferential statistics builds upon descriptive statistics. Very correct, because before you can make inference about any data, the data must have been collected, the data must have been organized. So to make an inference is to hypothetically make a report on what you observe about the data, and so on. Example of inferential statistics, we'll look at antibiotics. For instance, reduce the duration of viral throat infection by 1 to 2 days. 5% of women aged 30 to 4 consult their GP each year with heavy menstrual bleeding. All these are just hypothetical statements, and because they are hypothetical statements, we regard them as inferential statistics. So these are the various stages involved in statistical investigation: a collection of data, organization of data, presentation of data, analysis of data. Oh my God, this is very important. This point number 4, analysis of data. It is at this point you will be making sense from the data. In fact, this is very important. You need to take note of this guy as if your life depends on it. Another important ingredient is this point number 5, interpretation of data. You must know how to interpret data. Very, very important. In fact, it is a skill on its own that you must have as a biostatistician in the making. So definition of some basic terms. Population, number 1. You see, population is the complete set of possible measurements for which inferences are to be made. Census is just a complete enumeration of the population. A sample is a subset of the population, that is a measurement derived from the population. Then this parameter is just a characteristic or measure obtained from a population, such as mean, the sample mean, the sample variance. All these are just parameters. This is not statistics. This is statistics. That is, there are no gaps between values. And we have method of collection of data. We have the primary data, the secondary data. Just as the name implies, primary data means that the data was gotten directly by you, while secondary data means that you got the data from a third party. Then we have scale of data, that is the scale of measurement. We have the nominal, they have the ordinal, they are the interval, and the interval ratio. Oh my God, there are about 4 in number. These 4 are very important. You need to study these 4 as if your life depends on it. Very, very important. Example of a nominal data is the marital status, the gender, which is known as sex. Then the ordinal data, these are data we represent in an ordered series. Okay, example, our level of education, Interval, their examples are temperature. Then we have the ratio, there are variables such as weight. Very, very important aspect of this course. Then in organizing data and presentation, we need the frequency table, we need the frequency histogram, the relative frequency, up to the bus plot chart. These are the tools. These are more or less like a skill that you will get in this course by the time we look at the nitty-gritty of this course. This is a very interesting course. Very, very interesting. So frequency table, we'll pick this one after the other and see how we go about it. What is the frequency table, by the way? The frequency table generally is just a table to organize your data. Okay, it's just a table to organize your data. In fact, that is the first point of contact you will have when you want to make sense from your data. That's the first point of contact in order to investigate your data. Okay, we look at an example here. We were told that a researcher or a research study shown that conducted somewhere showed that the number of children in a family living in a community, a sample of 30 were picked. Suppose this community is Okoirese community. Maybe there are 1 million people living in Okoirese. They just selected 30 from that community. And the data, you can see the way the data was given in an unorganized manner. We have 2, 2, 5, 3, 0, very scattered. The data is scattered, and the example said we should organize this data in a frequency table. The keyword is this: we should organize this in a frequency table. How do we go about it? Fantastic. The first thing to do is to outline the number of children in that sample. That is, we start from ascending order. Ascending order means that we start from the smallest to the highest. We have 0, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 children. 8 children. So the number of family with no children are 2. That is the essence of this frequency. Then the number of family with 1 child is 2. So that is the building of the frequency table, and so on and so on. There's another example here that shows how you should go about the frequency table. Just as the first example, same thing applicable here. The measurements are scattered, very, very scattered. You need to make sense from measurement. And to get the relative frequency, very easy. Just pick the frequency to be divided by the total number of data involved there. So you group them by age groups. We have 30 to 36, 37 to 41. So you go into the data, look for age group that falls between 30 to 36, and you will be fine. Very interesting. You see, we were given a scattered data. Now we have a data that makes more sense. So this is an assignment for you to consume. It's a very simple assignment. You have to go through this slide once again and see the scale of data that was given: nominal, ordinal, interval, or ratio. What are you to do? All these variables, you will categorize them as maybe, if gender, for example, if it is nominal, you said it's nominal, so you can create a table in the format like nominal, ordinal, interval, ratio. Under nominal, you go into this variable and put the variable that belongs to all the scale of measurement. And that is the assignment for you. Thank you once again. If there is no question, we have come to the end of the class. Thank you.